Hi, so welcome to our first video about how the solar system got created. Now, of course, in the center of our solar system we do have our sun, and we're not going to talk so much about how that star gets created. We're going to wait until a little bit later in the semester to talk about how the star got created and what's going on inside that star while it's being created. This lecture is going to focus more on what's outside of where that star is forming. Alright, so let's take a look at what's going on to make a solar system, a planetary system. So everything that's made up in our world, right, all of the little tiny pieces that are inside of everything, these atoms, they were all produced right after the Big Bang. Okay, now right after the Big Bang we had mostly just hydrogen and helium. I know I'm not mostly hydrogen and helium, right? Neither are you. We've got carbon and oxygen and things like that as well. But right after the Big Bang, right, the start of the universe, there was mostly just hydrogen and helium. So you kind of wonder, well, how did we get all this carbon and oxygen and stuff? That all happened inside of other stars. So everything that makes up your body, other than hydrogen and helium, was formed inside of another star. Now, stars can only make stuff up to about iron in the periodic table. So everything after iron in the periodic table, right, the good stuff like gold and things like that, those are produced in big supernova explosions. And that's what you're seeing here. This is an image of a supernova remnant here. There was a star inside here, and when that star explodes, it spreads its guts out into space, right? This all used to be part of the star. This material, because there's such a high energy explosion, this material can make even heavier elements out there in that explosion. And we'll take a look at those a little bit later as well. Okay, but everything that's in you was once in something else before. Okay. Recycling. Okay. So stars are born, they die, right? They live for a certain amount of time. It's a lot like people. Okay, so in this image we've got some little stars that are just about being born there, right, in those little tiny clouds. We've got some really young stars still in their little birth cocoon, right, still in a little shroud of dust there. And then we've got some old stars there. There's an aging supergiant. At some point, that star right there will explode in a nice big supernova. It'll spread its material out into space. That material will recollect in various ways into probably a new star. Okay, it'll disperse, it'll become part of another cloud, and then that cloud will give birth to new stars. Okay, so the material gets used over and over and over. The universe is really good at recycling that material over and over and over again. Okay, so stars are born, stars live, they produce heavier elements inside their core, then they die, they return all of their material back into space where it can form new stars that make heavier material, right, around and around and around. Okay, so everything that's not hydrogen and helium was once in some other star, was once in a supernova explosion. Okay, so because our Earth is not mostly hydrogen and helium, you know that the area where our solar system was created must have had some supernova explosion nearby at some point. That material then was able to collect into this new star, our sun, and the planets that go around it, one of which is our Earth. Okay, so you are star stuff. This is what Carl Sagan talks about when he says that you are made out of star stuff, because you are. All of the material that makes up you, that makes up your house, that makes up Earth, was once inside of some other star somewhere. So, let's talk about how we got those planets. There are a couple of different theories for how we got the planets. The first one is largely discounted now. We don't believe this one. But their first idea was maybe it was a kind of a catastrophic thing. We thought there was only a few planetary systems out there. So if there's only a few planetary systems out there, maybe it was an accident that we got created. Okay, that was the thinking behind this. So they thought maybe there was some sort of passing star. This passing star took a little bit of material out of the sun, and then they could form some planets around there. Okay, well, if that were the case, right, that would be fine as long as we didn't find planetary systems everywhere else. Right? This sort of hypothesis really means that this is an accidental thing. It's not a common thing. So when we look at other stars and we find planetary systems now around just about every star we look at, it kind of makes this one seem really, really untrue. Okay, this one's really, it's no longer considered to be an accurate hypothesis. So what's our new going hypothesis? Because we find these systems around almost all stars, we think it's a natural hypothesis. Okay, that this happens naturally as the star forms. The material that doesn't quite make it into the star itself makes little balls that go around the star. We call those the planets. Okay, this is what's also known as the nebular hypothesis. Right? A nebula is just a fancy word for cloud. Okay, so we're going to take this cloud of material, we're going to make a star in the center, and the rest of that material as it goes around is going to be where the planets are made out of that material swirling around. Okay. This, like I said, predicts that most stars should have planets. And that's not what we're finding, right? Our telescopes have gotten better and better so that we can see these little tiny planets going around these faraway stars. We see this sort of thing happening in what we call the T Tauri stars. They were found in the Taurus constellation, hence the Tauri part. Okay. Our system probably formed just like this about 5 billion years ago, right? About 4.6 billion years ago. All right, so what needs to happen to make a planetary system? Well, we've got that cloud. That cloud, it's going to have some motion to it, right? Maybe it's rotating a little bit. It's going to have some motion. As that cloud collapses, that motion's going to intensify. Okay? As it collapses, the cloud's going to heat up. Okay? As material falls towards the center, it speeds up, just like things that fall towards Earth speed up. As that material falls towards the center of the cloud and gets pulled in by gravity, that material is going to move faster and faster. We translate that as heat. Okay, so this cloud's going to heat up. It's going to become the hottest there in the center where the star is going to form, but it'll be hot kind of anywhere in this inside region, right? Getting cooler as you work your way out to the edge. Okay, so it's going to get hotter. This is good because stars are hot. Okay, it's also going to start spinning. So it'll have some sense of motion when it's big, but as it gets smaller and contracts, it's going to spin faster and faster and faster, right? Just like figure skaters, right? With their arms out, they're not spinning that fast. When they pull their arms in, they're really going to spin a whole lot faster. So that's what's happening here. So we're going to start this disk spinning around. Okay, now the oddest thing is, right, notice that this is round like a sphere and this is flat like a disk. What's up with that? Okay, this flattening happens because of collisions that are within the cloud. Okay, the only thing that's left after all of those collisions is this residual around motion, right, in the disk. Right, any of the up and down motions have canceled out through those collisions, leaving it with just the motion around the disk. Okay. Out of this disk, we got all of our planets. Okay, so let's look at what kind of planets we have, because this is going to be important. We have two different kinds of planets in our system. We've got the ones that we call the terrestrial planets. Right? These are our rocky planets, Mercury, Venus, Earth, and Mars. Right? Here they are right here, Mercury, Venus, Earth, Mars. Just after them is the asteroid belt, kind of the dividing line between the terrestrial planets and our big Jovian planets. These are these guys out here. Jovian just means Jupiter-like. Okay, so these are our big gas or ice giants. We've got Jupiter, Saturn, Uranus, and Neptune. These two planet types are very different from each other. You cannot say that they're alike in very many ways. Okay? They definitely all go around the sun. They were made out of that same cloud, but they're very different kinds of things. Which maybe makes you wonder, if they all got formed from that same cloud, how did we get two different kinds of planets? We'll talk about that in a little bit.